So recall that point M is the midpoint of segment PQ if M is between points P and Q and PM equals PQ. So if you have a segment PQ and a point M between P and Q, then PM is going to be equal to MQ. This should be MQ, not PQ. I don't know why it says P. That's an M. So there is a formula for the coordinates of the midpoint of a segment in terms of the coordinates of the endpoints. So your formula for midpoint is x sub 1 plus x sub 2 divided by 2 and y sub 1 plus y sub 2 divided by 2. Okay, so you're averaging your x's and you're averaging your y's. So if I have my point P, my point Q here, you have x sub 1 from P right here and x sub 2 from Q right here. So taking x's from both points, add them together, divide by 2. Y's from both points, add them together, divide by 2. Okay, that's all you do to find that midpoint. So in example 1, we want to find the coordinates of the midpoint of segment AB when A is 5, 12 and B is negative 4, 8. Okay, so in A, I would have x sub 1 and y sub 1. And B, I would have x sub 2 and y sub 2. So I can then use my formula that I highlighted here to find M, which is that midpoint. Plugging in, x sub 1 is 5, plus x sub 2 is negative 4. That's divided by 2. This is a point, so yes, you need the comma there. Then I have y sub 1, which is 12, plus y sub 2 is 8. And that is divided by 2. Okay, whenever you're looking for a midpoint or a coordinate, you should always keep it in coordinate form. Okay, from here I'm just going to simplify. So I have 5 minus 4 is 1, and 12 plus 8 is 20. Okay, so I can either keep this as 1/2 10, or I can change it to 0.5 if you'd like. Okay, so either or, both of those answers are correct. Okay, so you're just plugging it into that midpoint formula, and again, it is a midpoint, so it has to be a coordinate. You have to have that comma between. You're not adding the two numbers together, anything like that. Okay, questions on midpoint? Is that coming back to you? You remember how to find the midpoint? All right. Then the distance between 2 points, A and B, on a number line is the absolute value of A minus B, or the absolute value of B minus A. You can use this fact and the Pythagorean theorem to derive a formula for the distance between 2 points on the coordinate plane. Okay, so let D represent the distance between x sub 1, y sub 1, and x sub 2, y sub 2. So recall the Pythagorean theorem is a squared plus b squared is equal to c squared. So on that graph, you can kind of see that right triangle created between your 2 points with your rise and your run. Okay? So this length right here is opposite that 90-degree angle, so that would be c in the Pythagorean theorem. Okay, your other two sides would be labeled A and B. Okay, so this is A and this is B. So I can plug those values in to the Pythagorean theorem. So for A, I have x sub 2 minus x sub 1. Okay, and A is squared, so I have to square that value. Plus our B value here is y sub 2 minus y sub 1. And again, B is squared, so I can square that quantity. Okay, and then C is this D value right here. Okay, so if I'm trying to find the distance of that line, I just want that D value by itself. So I would take the square root of both sides. Okay, then I end up with just D, or distance, is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. That is your distance formula, and that's how it is derived. Okay, so that's where it comes from, using that Pythagorean theorem. Okay, so next we are going to use the distance formula. I want to make sure everybody's with me here. Yeah, you. Yep, I'm sure. So on the back, the distance formula again is written out for you here. So that's square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So just like with midpoints, I do like to label each of your coordinates given. That way it's easier to plug into your formula. So example 2, it's not just giving you 2 points and saying plug this in. Okay, you actually have to figure out what those 2 points are. So Sharon hits a golf ball 12 feet above the hole and 3 feet to the left. So I'm going to start off by just drawing a picture here. Okay, so she hits a golf ball 12 feet above that. So we have to go up 12, right? And then to the left 3 feet. So we'll go to the left here, 3 feet. Now if I'm going left, think about a graph. If I move left, what does that mean the value of it is? It's negative. Okay, so if I'm moving left, your value is negative. So I'm just going to write it as -3. So her first putt traveled 2 feet above the cup and 1 foot to the right. So I need to find where I'm going up 2 feet and then to the right 1 foot. Okay, so we're trying to find this distance of her putt right here. So I need to figure out what the coordinate point would be here and what the coordinate point would be here if this is the origin 0, 0. So with this point, from 0, 0, I went right 1 and up 2. Okay? Right 1, up 2. So that would be 1, 2. With this point, I have left 3, okay, and up 12. So that would be -3, 12. Okay, you always do left or right first and then up or down when you're labeling your points. Okay, so now I have my 2 coordinate points. So I have -3, 12 as 1 and 1, 2 as the second one. Now, since I'm using the distance formula, I want to label my given points now. So this first one I can label as x sub 1 and y sub 1. The second one as x sub 2 and y sub 2. So now that I have my points and I have them labeled, I can just plug them into that formula. Okay, so we're finding that distance. Okay, we need x sub 2, which is 1, minus x sub 1 is negative 3, and that quantity is squared, plus y sub 2 is 2, minus y sub 1 is 12, and that quantity is squared. Okay, from here you want to simplify. So I have 1 minus a negative 3. Okay, so that's really 1 plus 3, right? So that's 4. 4 squared is? Okay, I have 2 minus 12, that's negative 10. Negative 10 squared is what? Positive 100. Okay, if you square a negative, it is positive. Square a negative, it is positive. So now I do have to add those together, which is the square root of 116. Now if you want, I don't care, you can leave it like that. But you can also plug it into your calculator. So the square root of 116 is about 10.77. And we are talking about feet. So that distance would be in feet. Okay, questions on that first one? Okay, we'll do one more with the distance formula here. So a coordinate grid is placed over a scale drawing of Nita's patio. A grill is located at 2, negative 3. Okay, so this grill, I'll label it as G, is located at 2, negative 3. A flower pot is located at negative 6, negative 1. Okay, so we have a flower pot, negative 6, negative 1. And then there is a picnic table that is halfway between the grill and the flower pot. So this picnic table is between those 2 points. In coordinate units, how far is it from the grill to the picnic table? So we have to find this distance between these 2 points. Well, first that means I have to find that picnic table's point, its coordinate point. Well, it's halfway between. What can we do? We can use the midpoint, right? The midpoint was on the front. Okay, that's averaging your x's and averaging your y's. Okay, so to find P, move up here a little bit. We're going to add our x values together. So 2 plus negative 6 divided by 2. Then we also have averaging our y's, so negative 3 plus negative 1 divided by 2. Okay, so we have 2 minus 6, it's negative 4 over 2. And negative 3 plus a negative 1, again, is negative 4 over 2. So the coordinate for that picnic table is going to be negative 2, negative 2. Now, is that what I had to find? No. I have to find how far it is from the grill to the picnic table. Okay, when it asks you how far it is, that's the distance. So now I have to use these 2 points here with that distance formula. So like before, I want to label these. So I have x sub 1 and y sub 1 for point G, which is the grill. And I have x sub 2 and y sub 2 for point P, which is the picnic table. So now I can just plug those values in to the distance formula. So we have the square root of x sub 2, which I labeled as -2, minus x sub 1, which is 2, and that quantity is squared, plus y sub 2 is -2, minus y sub 1 is -3, and that quantity is squared. Okay, next we just have to simplify. So we have -2 minus 2, that is -4. It's not 0, it is -4. Okay, -4 squared would be what? 16. Here I have -2 minus the -3, so it's really -2 plus 3, which is 1, and 1 squared is 1. So I have the square root of 17, which again, you could just leave it like that. That's fine. I'm okay with that. Or if you plug it into your calculator, you get about 4.1 units. Since we're talking in units, it didn't say feet or meters or inches. Okay, so just in units. Okay, so that one did have a two-step answer there. You had to find the midpoint first because it said it was halfway between, and then find the distance between those 2 points. Okay, questions on midpoint or the distance formula?